So when we do arithmetic to them, polynomials behave like numbers, with the terms taking place of the digits. So where we did long division to numbers, digit by digit, we're going to do long division to polynomials, term by term. We're going to use the same basic process. So divide, multiply, subtract, bring down. But it's going to look a little bit different with polynomials than it did with numbers. We will set up our division bracket exactly the same way, with what we're dividing by outside and what we're dividing into inside. And notice we left some space between these terms inside. That's to give us room to write in. So for the divide step, we will look at just the first terms. We'll take 4x to the fourth divided by 2x squared. Well, we've got 4 divided by 2 is 2. X to the fourth divided by x squared is x squared. So the first term in our quotient is going to be 2x squared. And then when we multiply, we're going to take that 2x squared and multiply it by our entire divisor. Which is going to involve distributing. 2x squared times 2x squared is 4x to the fourth. 2x squared plus x is 2x to the third. 2x squared times negative 3 is negative 6x squared. So when we multiply, we need to distribute. So we write that product underneath here. And now, according to the process, it's time to subtract. Now, this can get tricky because unlike the situation with numbers, we can have negative coefficients here. So when we're subtracting, we're going to watch the signs. So 4x to the fourth minus 4x to the fourth is 0. Negative 4x to the third minus 2x to the third is negative 6x to the third. Negative x squared minus negative 6x squared is positive 5x squared. We can do that on the calculator. Negative 1 minus negative 6 is positive 5. Some people like to go through and annotate what the effective signs are going to be when they subtract. Right. If you find that helpful, please definitely go through and do that. But now, of course, instead of bringing down a digit, we'll bring down the next term. So here our next term is going to be plus 13x. And now we just restart the cycle. So now we look at the first terms again. We've still got a 2x squared there. We've got a negative 6x to the third. Negative 6x to the third divided by positive 2x squared is going to be a negative 3x. The next term in our quotient is going to be a negative 3x. That was the divide step. Now we want to multiply. negative 3x times my divisor will give me negative 3x times 2x squared is negative 6x to the third. Negative 3x times x is negative 3x squared. Negative 3x times 3 is positive 9x. So we write that underneath. Negative 6x to the third minus 3x squared plus 9x. Subtracting. Negative 6 minus negative 6 is 0. Positive 5 minus negative 3 is positive 8. So we've got positive 8x squared. Positive 13 minus positive 9 is positive 4. So we have positive 4x. That's the subtract step. And now we bring down the next term. We have a negative 12. Okay, that's it for that round. Now we continue to look at the first terms for the divide step. We have 8x squared divided by 2x squared is just going to be the number 4. The last term of our quotient is just the number 4. And now we multiply. We take our 4 times our divisor. That's 8x squared plus 4x minus 12. We subtract, we're taking something minus itself. We just get 0. So our quotient is just this 2x squared minus 3x plus 4. And we have no remainder. What that means is when we say that 4x to the fourth minus 4x to the third minus x squared plus 13x minus 12 divided by 2x squared plus x minus 3 is 2x squared minus 3x plus 4. What that means is that if I multiply these two trinomials, I ought to get my original polynomial back. Of course, we can check that by actually doing that multiplication. So I'm multiplying trinomials. I'm going to use the area method. 2x squared times 2x squared is 4x to the fourth. 2x squared times x is 2x to the third. 2x squared times negative 3 is negative 6x squared. 2x squared times negative 3x is negative 6x to the third. Negative 3x times x is negative 3x squared. Negative 3x times negative 3 is 9x. 4 times 2x squared is 8x squared. 4 times x is 4x. 4 times negative 3 is negative 12. Adding up the like terms on the diagonals, we get 4x to the fourth minus 4x to the third minus x squared plus 13x minus 12, which is what we hoped we would get. That division then does what we want division to do. It does the opposite of multiplication.